Whether you're an engineer, electrician, facility manager, or just getting into the electrical trade, at some point, someone's going to hand you a one-line diagram and expect you to make sense of it. One-line diagrams, also called single-line diagrams, are the roadmap of any electrical system. They show how power flows from the source all the way to the loads without the clutter of showing every single wire. In this video, we're going to break it all down. By the end, you'll know how to read a one-line diagram with confidence, what the symbols mean, how to trace power flow, and what to watch out for. Let's get into it. First, why one line? In reality, a three-phase electrical system has three conductors, three separate wires carrying power. Drawing all three would make diagrams extremely complex and hard to read, so engineers use a single line to represent all three phases. It's a simplified, symbolic representation, and once you understand the conventions, it actually makes the system much easier to understand at a glance. One-line diagrams are used for power distribution systems in commercial and industrial buildings, utility substations, generator and emergency power systems, facilities planning, and electrical coordination studies. Think of it as the big picture diagram. It tells you what's in the system and how everything connects, but not the detailed wiring. Now let's go through the most common symbols you'll encounter. Don't worry about memorizing all of these right now. Keep a reference sheet handy until it becomes second nature. The utility source. At the very top of almost every one-line diagram, you'll find the utility source. This is where power comes from. It's usually shown as an arrow or a set of lines representing the utility company's feed. You'll often see a voltage label here, like 13.8 kilovolts or 4.16 kilovolts. Also pay attention to fault current as another potential data point. Transformers. Transformers are two sets of curved lines facing each other. You'll see the voltage on each side labeled, or sometimes shown as two circles touching each other. For example, 13.8 kilovolts on the primary side, stepping down to 480 volts on the secondary side. Pay attention to the transformer's kVA rating. This tells you how much load it can handle. Also pay attention to percent impedance and the X to R ratio as other potential data points. Buses. A bus is shown as a bold horizontal or vertical line. Think of it as a distribution point. It collects power from a source and distributes it to multiple circuits. Buses are almost always labeled with their voltage level, along with other potential data points, such as AIC rating. Breakers and fuses. Circuit breakers are shown as a small square or an X across the single line. Fuses appear as a small rectangle. Both serve as overcurrent protection devices. They interrupt the circuit if too much current flows. You'll often see the breaker's ampere rating, like 400 amp or 1200 amp, and its interrupting capacity, like 65 kAIC, and other breaker settings noted nearby. Disconnect switches. A disconnect switch looks like an angled line, like a blade that can be opened. These are used to isolate equipment for maintenance. If it has a box around it, it's likely a fusible disconnect. Meters and instrument transformers. Circles with letters inside represent metering devices. A is an ammeter, V is a voltmeter, W is a wattmeter, and kWh indicates an energy meter. You'll also see CTs, current transformers, and PTs, potential transformers, nearby. These step down current or voltage to a safe level for metering. Generators. A generator is shown as a circle with a capital G inside. You'll see its kW or kVA rating, voltage, and often the transfer switch that connects it to the system. Motors and loads. Motors appear as a circle with M. Other loads, like lighting panels or HVAC units, are often shown as boxes or triangles with labels. Now that you know the symbols, here's how to actually read the diagram. Start at the top and work your way down. Power always flows from source to load, from the utility at the top, through transformers, through buses, through breakers, and finally to the loads at the bottom. Following that path is how you trace the system. Let's walk through a simple example. Here we have a utility feed coming in at 13.8 kilovolts. It hits a main disconnect switch, then flows into a step-down transformer, 13.8 kilovolts on the primary, 480 volts on the secondary. On the 480 volt side, we have a main circuit breaker rated at 2000 amps. From there, power flows onto the main 480 volts bus. Off that bus, we have several feeder breakers, each one feeding a different load. One goes to a motor control center, one to a lighting panel, and one to a smaller step-down transformer for 120 to 208 volt loads. Notice how every segment of the diagram is labeled. That's not decoration. Those labels are your reference points for protection coordination, load calculations, and troubleshooting. What to look for as you read. Voltage levels at each bus or transformer secondary. This tells you the system voltage at that point. Breaker ratings. Ampacity tells you the circuit's capacity. Interrupting rating tells you its fault protection capability. Redundancy or alternate feeds. Some systems have 2 utility feeds or a tiebreaker between buses for reliability. Emergency or standby systems. Look for generators and automatic transfer switches, which appear when utility power fails. Every professional one-line diagram will have a title block, a legend, and often a notes section. Don't skip these. They contain critical information. The legend defines what every symbol means on this specific diagram. While most symbols follow IEEE standards or ANSI standards, variations exist. Notes often contain specifications that don't fit neatly into the diagram. Things like conductor sizing, conduit types, grounding requirements, or references to other drawings. The title block tells you the project name, drawing number, revision history, and who drew and approved the diagram. If you're working from a revision that's not current, you could be looking at outdated information. Always confirm you have the latest revision. Before we wrap up, here are a few mistakes people commonly make when reading one-line diagrams. Assuming the diagram is current. Electrical systems change over time. Equipment gets added, replaced, or reconfigured. A diagram from 5 years ago may not reflect what's actually installed. Always verify in the field. Ignoring the voltage levels. Working on the wrong voltage level because you misread the diagram can be dangerous. Always confirm what voltage is at the point you're working on. Confusing open and closed switches. A normally open device means it's open under normal conditions. A normally closed device is closed. These affect how power flows and where it doesn't, not following the entire path. If you're trying to find the source of power to a specific load, trace the entire path. From that load all the way back to the utility, there may be intermediate breakers or disconnect points you'd otherwise miss. One-line diagrams are one of the most powerful tools in electrical engineering and maintenance. Once you can read them fluently, you can understand any electrical system at a glance. The key is practice. Find a one-line diagram for a building or system you work with. Trace the power flow yourself. Look up any symbols you don't recognize. Over time, it becomes second nature. Now that you know how to read a one-line diagram, if you need one created or updated for your facility, eHazard can help. We also offer a full suite of electrical safety engineering services, arc flash studies, safety audits, program development, NFPA 70B support, and lockout-tagout procedures. And if you're looking to train your team, we've got you covered there too. From low and high voltage qualification to arc flash, NEC, Train the Trainer, EV, and telecom safety courses. All available in person or remotely. Reach out to us at sales@ehazard.com and let's talk about what we can do for you. If you found this video helpful, give it a thumbs up and subscribe for more electrical content. Drop your questions in the comments. We read every one. Be sure to follow us on our social media pages, which are listed in the description. You can find our podcast listed there as well. Thanks for watching.